Hello there. I'm Tony Ferguson, one of our department managers in our Power, Instrumentation, and Controls department, where we provide electrical engineering services to our customers in industrial manufacturing facilities. At Matrix Technologies, we are a one-stop shop in offering consulting services for any process, facility, or automation need. Our team environment provides an in-depth knowledge to strive to provide our clients with a better process for success. At Matrix, we are involved in many different industries, including but not limited to food and bev, oil and gas, chemical, aggregates and mining, and metals. Each one of these industry brings along unique hazards due to the processing of raw materials to make finished goods. One specific industry that we are going to focus on today is feed and grain, which is part of the food and beverage market sector. Most feed and grain facilities start with the handling of grain where hazards can be present during normal operations. To mitigate these risks, awareness needs to be brought in best practices for grain hazard monitoring. Grain hazard monitoring is an extremely important safety focus to help reduce the chance of an event transpiring at a manufacturing facility that could cause harm to personnel, the facility, or even cause fatalities. Events typically involve a fire due to the hazardous nature of grain dust, which can also cause an explosion. In this presentation today, we will take a look at why it's required, what are the general topics to discuss, and tips and tricks on how to maintain it and best practices of grain hazard monitoring. The purpose of this presentation is to bring awareness to hazards of handling grain, as fires and explosions can be present if proper procedures are not followed. During the 1970s, several major grain dust explosions were experienced throughout the country, totaling close to around 60 fatalities, with additional personnel being injured due to the events. Due to this increased events, OSHA began to investigate and issued a grain elevator hazard alert to bring more awareness to these growing situations, as the storage of handling of various grain products has the capability of generating grain dust fires, which in turn can cause explosions. The grain elevator industry hazard alert was more formally developed into the OSHA standard, which became known as 29 Code of Federal Regulations 1910.38 and was distributed in 1987. This document captured industry consensus standards, which played an important role with helping reduce explosions, mitigating the risk of injuries, and ultimately reducing fatalities. Unfortunately, there are still explosions that happen in the grain industry today. The photo on the screen shows a recent combustible dust explosion within the past couple of years at a dry corn milling facility. This event, unfortunately, included several fatalities as well as injuries. The explosion luckily happened during a third shift where reduced staff was present, but still injuries were had. CFR 1910-272 covers many topics such as emergency action plan, training, hot work storage bin entry, flat storage entry, housekeeping, filter collectors, preventative maintenance, grain processing equipment, emergency escape, grain dryers, bucket elevators. Today's discussion will focus around the requirements of the control associated with equipment with grain handling facilities to help with identification of safety hazards to prevent grain dust hazards. CFR 1910.272 applies to grain elevators, feed mills, flour mills, rice mills, dust palletizing plants, dry corn mills, soybean flaking operations, dry grinding soy cake, and many others. Grain handling facilities that are also located next to a body of water may require additional requirements such as marine and OSHA compliance directive for those facilities. Again, today we're going to talk about the major topics of 1910-272, which require training of facility, emergency action plan, dust filter collectors, preventative maintenance, grain dryers, bucket elevators, and emergency escape. For emergency escape, a facility must provide two means of escape from galleries or grain bin decks, and tunnels must have at least one means of emergency escape, and if built after 1987, they must include at least two. Employers are required to provide annual training around the hazards involved with grain handling. Typically, this is provided in annual site safety training refreshers, but can also be obtained via outside sources such as the Grain and Elevator Processing Society, JEEPS, Feeding Grain Magazine, and/or equipment manufacturer presentations. Topics to include for training are recognition and prevention measures for reducing hazards due to dust accumulation, how to properly clean equipment, clearing choked conveyors, preventative maintenance, and lockout-tagout procedures. Entry to confined spaces such as bins, silos, bowls, and other processing equipment needs to be detailed specifically to reduce engulfment and mechanical hazards. Permits must also be used for entry of such bins and also when performing hot work in grain areas. Permits are required to cover any hazards dealing with grain. Typically, most dust collection systems will have different pressure gauge on the unit for manual inspections. Newer dust collectors, and one specifically used on larger multi-equipment systems, will include some measures and means of verifying pressure through control systems. These are typically interlocked to run systems for controls to allow equipment to run. Best practice design for dust collectors would be to locate units outside. I've recently seen a trend of these units being placed on rooftops or older facilities or spaces at a premium. Attention to detail around how the dust filters will be maintained needs to be taken into consideration to allow access for platforms and rigging of hoists to help move larger equipment around to maintain the dust collectors. There are several different methods of explosion suppression out there and available for dust collectors, including steam, chemical isolation, and also more commonly explosion venting. Most sites will typically rely on both isolation and suppression for dust collectors, and it is important to document these within each facility. Under OSHA 1910.272, preventative maintenance is a key part to maintaining a facility. Many issues that are caused by lack of maintenance of proper instruments or equipment is typically the main root cause of issues which can cause fires and or explosions. Devices that are found to be not functioning properly at the facility need to be replaced immediately. Keeping spare and store stocks replenished for emergency service is also a good recommendation for operations. Grain dryers are a crucial part to most grain handling facilities. This allows the flexibility to store both wet and dry products at a given facility. In addition to the requirements of OSHA, NFPA 86 also provides some guidance for standards on ovens and furnaces to help identify instrumentation controls required for the burner management systems. These requirements typically drive most grain dryer manufacturers to supply a separate control system used by the grain dryer, but care needs to be designed when implementing or migrating these systems into a plant-wide control scheme to make sure all requirements are held. Some grain dryers will also have multiple gas trains or heating elements for different zones, which each need to follow the same guiding principles. It's common in older facilities to see several different vintages of equipment installed. Older systems typically relied on hardwired relay timer logic, whereas newer systems are coming supplied with safety PLCs. It is also common to see older grain dryers abandoned in place, and if they were built into existing head houses, bins, or other configurations where removal of equipment is difficult, they still may reside at the facility. Care needs to be taken to remove any electrical or heat sources to ensure the system cannot be started back up without required upgrades to meet code compliance. OSHA 1910 also requires leg conveyor instruments for monitoring of grain hazards. Bucket elevators or leg conveyors are not to be jogged to free a choked or buried leg. Access needs to be available at the head and the boot in order to dig out conveyors in the event, along with provide means for inspection. Belts installed after 1990 and 1988 are also required to be conductive, typically made from a synthetic fabrics to discharge electrostatic charged when conveyor belts are running per ATX standards. At a minimum, best practice on conveyors is to monitor bearing temperatures at the tail and heads of the legs. This is done by installing bearing temp sensors on both sides of the conveyor. If knee pulleys or take-up pulleys are used, typically these are also monitored as they provide separate potential heat source for issues to reside. A network of devices is typically installed to monitor these sensors, and it can be provided from such manufacturers such as CMC, 4B, Electro Sensors, and many others. Motion sensors are also used on the tail or knee pulley to monitor actual speed or provide a speed switch that monitors the conveyor that at the event it starts to operate at a speed lower than 20% of normal speed, the conveyor is interlocked to shut down. Rub blocks are also used to determine when conveyors get off track and have potential to rub up against obstructions, causing heat, which can get hot enough to start a fire. Mechanical alignment ruler guards can also be used to help keep conveyors on track. Most companies will have a safety standard which will guide the minimum requirements in conjunction with OSHA and their global safety standards. Typically, additional belt conveyors on top of leg conveyors are usually monitored with such hazard monitoring systems. In addition, there are requirements to need either a fire explosion suppression system or a dust control system to verify that the dust is being mitigated to lower than 25% of the requirements for explosions. Seeing a trend in industry of both requiring the explosion suppression and the dust collection at manufacturing facilities. In addition to OSHA requirements, NFPA gives many different standards in revolving around operations of a explosive environment. In addition to the OSHA requirements, NFPA helps guide along with insurance requirements to make sure facilities are following proper procedures. Some of these can be seen here on the screen and are available online at nfpa.com. Two specific ones I wanted to point out as part of this presentation were NFPA 69, where there are alternate options for explosions protection systems. Some of the most common that are seen out in the market today are chemical suppression, active and passive isolation, and pre-deflagration detection along with controlling ignition sources. NFPA 70 also provides guidance in how to install conduits, cables, wires, and other electrical equipment that goes in conjunction with grain hazard monitoring. In summary, I hope you have learned about some of the instruments and monitoring system requirements of grain hazard monitoring. Matrix has trained and experienced personnel to help identify and mitigate grain hazard risks. When applying our knowledge, we are platform independent and can interface with a wide variety of hardwired to fully automatic control systems. We partner with local contractors for installation, providing a full turnkey solution. To learn more about Matrix and our offering, head over to our website at www.matrixti.com and our Matrix on Manufacturing section to learn more about us. Thank you for taking the time to listen to my presentation, and do not hesitate to reach out with any questions or comments.